Okay, now we're going to look at an example of taking a problem and creating a table of values based on a word problem. We look at this problem right now. We have Panago Pizza charges $11 for a medium cheese pizza, plus $2 for each topping. We have an equation for this relation, is C equals 11 plus 2n, where n represents the number of toppings and C represents the total cost of the pizza in dollars. And we're going to use this equation to create a table of values. So the first thing we're going to do is we're going to say, okay, well, you can order a pizza with no toppings, right? Some people just like cheese pizza. So no toppings. Then in our table of values, we would have n equals 0. So if we write this out as an equation, then we have C equals 11 plus 2n, which would be written like this. And C equals 11 plus 2 times 0. We'd say C equals 11 plus 0, which equals $11. Okay? So our first pizza costs $11. Well then, if n equals 1, if we have one topping, right, we go C equals 11 plus 2 times 1, and C equals 11 plus 2, where we have C equals $13. Okay, so we have $11, $13. If we start to create a table with this, all right, and I'm going to create this table, oh, maybe I'll just create it on the side here. So we have our input is n, and our output is C, then our table is going to look like this. We start with input of 0. The output is $11. If we have one topping, our output is $13. So our constants, when we're looking at our constants here, we're adding 1. All right, when we add 1 here, when we add a topping, our price goes up by $2. Let's check this out see if the rule holds true for 2 toppings. So if we have C equals 11 plus 2 times 2 toppings, n is 2, then we get C equals 11 plus 4, and C equals 15. So when we have 2, we get 15. So again, our table of values shows that we're adding 2, all right? So then, I can simply go, okay, well, if I go 3 then, oops, sorry, I made a mistake here. We're adding 1 on this side, plus 1, plus 1. Stay consistent with my colors. We have 3, then we're going to add 2 to 15, that's going to be 17. 4 would be 19. Okay? So now, we take a look at this and we go, okay, we'll use the equation to find the cost of a pizza with 5 toppings. All right? So we can simply do that. We can go C equals 11 plus 2n. So we simply say C equals 11 plus 2 times 5. All right? C equals 11 plus 10. And then we have our cost. C equals $21. Okay? And that's the cost of a pizza with 5 toppings. And we look down here, well, what if we use the equation to find out how many toppings are on a pizza that costs $27? Right? So now we've changed it up a bit. We have the total cost, which would be C, is 27, equals 11 plus 2n. How many toppings are on that? Then we're back to our regular algebra stuff that we were doing before. So we would subtract 11 from here and 11 from here, and we'd end up with what is that? 16 equals 2n, and then we divide by 2 and divide by 2, so that we eventually end up with n equals 8. All right? And so there are 8 toppings on a $27 pizza. Okay? And that's how we're messing around with creating a table of values. Right here, creating a table of values that represent a linear relation. Okay?